Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. I've been out here with a telescope for the last couple of hours. We've been taking pictures of Orion, and I think it's just given up the ghost as far as being able to image it. It's getting the telescope into a very awkward angle, and it's not having much fun with it. So we lost our tracking there just a couple of minutes ago. So what I've done is I've parked the telescope. That means that I've pointed it back pretty much at the North Star, and we're going to sit down and we're going to have a look at it and see whether or not we can find some other objects. So the first thing that I'm going to do is take the camera off of SharpCap, and I'm going to go into Astrophotography tool. And while I'm waiting for that to boot up, I'm going to get Stellarium going. Okay, correct camera. Everything looks good there. Telescope's not moving, so we're just going to shoot an image real quick. Okay, so this is kind of in the vicinity of the North Star. I'm going to go ahead and just kind of talk you through it. I've got to look at the screen up here, so rather than bore you with the side of my head, let's just go ahead and make a full screen for you. Everybody hearing me okay, by the way? So we've taken a picture right here, and I'm going to go down here to something called Point Craft. I'm going to indicate I want the scope position put in. And there it is. We're up kind of at the North Celestial Pole, more or less. And we'll just go ahead and solve that real quick just to kind of get the scope oriented. It may take a couple of minutes, but what it's doing is it's looking at this image and it's trying to figure out what these stars are. And it has. So you see, it's identified where we are. There's the actual position of the scope compared to where it thinks it is. So you see it's a little bit off, not much. And we're going to go ahead and sync it right there. Now it's telling me something is not working right here, but what we're looking at here is the field of view. And we're looking at about 100 arc seconds this way, and we're looking at about 70 or 68.18 arc seconds this way. That is the direction to the North Celestial Pole, and the focal length of the telescope is 658.71 millimeters. So we're going to do a couple of things here real quick. We're going to go on over to Tools. Let's bring this out of the way. We're going to go on over here to Tools, and we're just going to put in 658. I know it's not that much of a difference from 660, but it's 658. Here's the information about the sensor in my camera. This is the ZWO-294 camera that Wolfie donated to the channel. So let's go see what's going on here. It doesn't want to sync. That's very strange, but it wasn't far off. So what we're going to do is I'm going to restart that real quick, and while we do it, I'm going to have a look here at Stellarium. So with Stellarium, what we're going to do is go up here to the settings box to plugins. And we're going to look down here at remote control of the telescope. Going to configure it. Now the telescope we're using is telescope number 1. Let's see if that'll connect. And it does. And that's where the telescope is pointing. So let's go down here and just have a look at a couple of cool things. Let's look at Bode's Galaxy. Bode's Galaxy is a nice spiral galaxy. Okay. I gotta unpark it real quick. My bad. Right here we'll unpark the telescope. That means that we don't have it locked pointed towards the North Star anymore. And we're going to go down here to Bode's Galaxy and see whether or not it'll slew over there. There we go. Now the telescope mount is trying to slew over to Bode's Galaxy. So now it says it's kind of pointing right at it. What we're going to do is go ahead and shoot an image. Okay, so there's the image. Now you don't see too much in here. You might see a little star right there. So this is what's called the histogram. You see this big peak right here? This is where all the data, all the light that the telescope's seeing is located. So what we're going to do is we're going to stretch it over there. And now, as you can see, we're seeing a couple of stars now. Now that we have the stars up here, let's go ahead and see where that is. So we'll go to Point Craft, put in the scope position, and see if it'll solve that. And, look at those stars and figure out what we're looking at. And as you see by this little compass, it's located where we are. Let's see if it'll sync. Now it's synchronized. So we'll go back over here to Stellarium. What we're looking for is this Bode's Galaxy right here. See? That's Bode's Galaxy, and that's the Cigar Galaxy, and that's the Garland Galaxy. And that right there is where the telescope is pointing. We don't want it there. We want to point it at Bode's. So let's slew it over and see if we're lined up now. So let's close that. Let's go ahead and shoot another picture and see what happens. Ah, there it is, right there. Now that is Bode's Galaxy. I don't really like astrophotography tool for doing the images. You can tell these are stars. That's actually a double star right there. But notice this is a little different. You see the smear around it somewhat? This is because this is a galaxy and these are stars. Now let's go see if we can get a little better view of this. We're going to go ahead and disconnect the camera. And we're going to go down here to SharpCap. And we're going to select our good color camera. This is the Wolfie camera. See how our image is all the way down here? But we got a couple of things to do first. We do need to make it a little richer image. It's set on raw 8 by default. We want to bring it up to raw 16. Next, the current exposure here is 50 milliseconds. We want to do a little longer than that. Let's do about 4 seconds and see what that looks like. Actually, let's go ahead and do 8. Now the gain, just knowing this camera, I want it just over 121. So let's go to 140, leave it right there. That's a good gain for this camera. And here is the image. Actually, if we make the gain a little bit greater than that, we may be able to move that image off the edge a little. Go up here to 237, see what that does. So that should bring it over just a little bit. Now by hitting this little lightning bolt, we'll do what's called auto stretching. And there's Bode's galaxy right there. Now, if you look right up here, there's another galaxy right here, and this is called the Cigar Galaxy. Now, when you're dealing with really faint deep sky objects like this, one of the things that you want to do is you want to use a little bit longer exposure time. So let's go see if we can do a little longer exposure time here. Let's go up to about 30 seconds and see what that looks like. Now it's going to take a couple of minutes to do it. You can see how long it's going to take to do it by looking at this bar right here. And while it does that, I'm going to go get something to drink real quick. I need a soda or something. Got some Mountain Dew and some orange soda here tonight. All right, now if you look at this carefully, you see the center of the galaxy right here, the center of Bode's galaxy, but you notice there's some spiral arms coming around. See those? Let's see if we go about a minute. See if we can get this a little better. A minute's a good amount of time for a galaxy. We'll see whether or not any satellites go by, because as it sits there and exposes the image here for a full minute, chances are a satellite may go by. They'll look like streaks. Okay, we're about halfway through the image now. This is, of course, a live image. All right, Sean, let's go see what kind of equipment that you have. I think you got some nice stuff, as I recall. So you see, here's this green is light pollution. I may be able to clean this up a little bit. I don't know. We'll see. I don't think we're going to be able to get rid of it. What we can do is we can try and stack this. Sean, send me a list of what you have. I'm not really in the market for more telescope equipment right now, but send me a list of what you have, and I'd like to have a look at it if you don't mind. Maybe get you helped out a little bit. Try this a little bit more down here. We'll bring it down to about 30 on both. See what that looks like. One thing that you want to do in astrophotography is first you want to make sure that you have good guiding, which means that you're matching the rotation of the Earth, and you want to have a good focus. And the way you tell that is you look at the stars. Are they very small and round? Are they oval shaped? Are they streaked a little bit? This guiding looks really good right now. So we've got a galaxy there and we got a galaxy there. I don't know. Let's drop this down. Let's go have a look and see what else we can find out here. Now, This is a 60-second exposure. I really don't want to be waiting on that, so I'm going to go ahead and drop it down to 8 for right now. Yeah, Sean, I don't know what a quark is. Is that special eyepiece that you had to look at the sun or something or other? But in any event, let's go see what else we have to look at here. So let's go down to Stellarium. I'm going to make that just a little bit smaller. So that may actually be the Garland Galaxy that we're looking at there. Let me check one other thing here. Yeah, that's on auto. Let's see what else is nearby. So here's Ursa Major, or the Plow, or the Big Dipper as we call it here in the United States. Gemini we looked at a little bit earlier today. I'm going to bring this down a little bit just to see where I am. You know, I haven't looked at any of these over here. I'm wondering if I can see the Elephant Trunk Nebula. I've not seen that yet, so let's see if we can see it together maybe. Boy, that's a big boy, isn't it? Let's go see what that looks like here. That's what the raw image looks like. Here it is with auto stretch. Now, I don't know if we're looking through a tree here or if this is just the nebulae. But I know there's a hell of a lot of green out there, even though I've got a light pollution filter on this. Maybe what I ought to do is put some hydrogen filters on this and just look at the hydrogen bands. It requires a lot of the gas clouds out there are hydrogen. So what happens with those is that you only see the color of light that hydrogen gives off. It doesn't see any of this green. Now the problem that you run into with these telescopes is lots of times, the bigger the telescope, the more magnification you get, which means the smaller your field of view is. So if you have a telescope, and if you have a telescope that is like Sean's, which is an 80 millimeter, which is a little smaller than mine is, it's got a much shorter focal length, and it's what's called a wide field telescope, which means that you can see a lot more. Now, for example, the Heart and Soul Nebulae is about 150 arc seconds square. As you saw there, I'm seeing 100 by 60 arc seconds, so I can't even see the whole nebulae. Now, when I get the hyperstar on the Meade 10-inch, assuming the Patreons are good to me, and we come up with a part of the $1,000 that costs, I'll be able to photograph an area of the sky about 200 arc seconds by 200 arc seconds, and I should be able to get both the nebulae in at the same time. Now what I'm looking at right now is I'm looking at these dark spots. And as you see, they are moving a little bit. I'm thinking there's a tree right there. I think I'm running into a tree, which isn't good. So let's go see if we can find a better image of something else that doesn't have a tree in the middle of it. There's Andromeda tonight. Now Mars is going to be too far to the west for me to get to right now. I don't know, maybe we'll see. Let's see if we can get Andromeda tonight. The way you find Andromeda, by the way, is first it's in the Andromeda Galaxy, or the Andromeda constellation, which as you see is right here. All right, this is the Andromeda constellation. But if you look up here at Cassiopeia, which is the W you see in the sky, look at the second side, the right side of the W. It almost points directly at it. And there's Andromeda right there. Now, if we want to line that up just a little bit better, let's go ahead and see what we can do about moving this around a little. Yeah, that's the way I want to go. That'll bring it up some. Good. Oh, wrong way. Let's bring it over this way a little bit. Yeah, that's what I want. Yeah, I'm pretty happy right there. One problem that I am seeing right here is that I've really got a lot of green. Let me go see if I stop this and then I restart it again. Let's see if I get a little better exposure with that. And while that's starting up, what I'm going to do is I'm going to start Discord in case you guys want to come in. We'll go to Mount Wolfie. Now while we're doing this, let's go ahead and restart Wolfie's camera here. And then remember what we want to do is we want to go from RAW 8 down to RAW 16. We're going to give it, probably, let's give it a second and get a 30-second exposure right there. That's a nice medium exposure. Now, when this gets done taking that picture, the Andromeda Galaxy should be right in the center here. And I'm going down here to Mount Wolfie. All right, first of all, here is the link to the Discord server. I'd appreciate it. Why don't you guys come on over if you wish, if you have Discord. Just give me a second. Give me a second just to put this up real quick and then I'll boy, it's taking its time to start. Here's the link to the Discord server, which I'm putting in chat right now. Come on over. Good night, Sean. Thanks for stopping by. There we go. There's the link to the Discord server. And if you go over to the Discord server, what you're going to see under the Bob the Science Guy server, you're going to see a place down here called Mount Wolfie Observatory, and IB Hunter's in there right now. Let me make sure the audio is good for that. Yeah, that should be good. IB, can you hear me?
Yeah, I hear you.
Yep, we got him. All right. So IB and I are over there. IB actually is a fellow amateur astronomer down south, giving me a lot of good advice on my astronomy. He's been doing it longer than I have. All right, so one of the things that I want to do is we've got a 30-second image right here of the Andromeda Galaxy, and you can't see very much on it because it's such a faint object. You can actually see this with your naked eye. You got a lot of noise coming out of here, IB. Yeah, mute up while you're, unless you're talking, if you would. So you can technically see this with your naked eye. And it's the farthest object that we can see with our naked eye. It's 2.5 million light years away. But remember I told you down here, here's the data. Here's the actual light coming from that galaxy. And here is our visual curve. So if we adjust that to match the light, there is the Andromeda Galaxy. Now you can clearly see there's some dust swirls right up in here. That's M110, which is another galaxy. This is Andromeda, which is M31. And this is another galaxy right down here called M32. Now, if you look at kind of the coarseness of this background here and how it just moved like that, I've got some clouds going overhead. So what I'm going to do is I'm going to set this up to a full minute, and I'm just going to go have a look at the sky real quick and see how bad those clouds are and whether they're really going to screw us up. Socialist Worker Drone is here in Mount Wolfie. Now, if you can't get directly into the Mount Wolfie Observatory, there's a waiting room for the Mount Wolfie Observatory just above it, and you can go in there and we'll pull you down. So I'll be back in just a second. I do want to have a look at that sky and see what it's looking like out there. I'm going to go on mute here momentarily. Meanwhile, if you want, you can check out our Super Chat and our Patreon and everything. The links to that are all in the description of this video. And while you're at it, go ahead and join Discord. We have a lot of conversations there about every day. Well, the clouds out there aren't too bad, but as you see, I'm starting to get some interference out in here. One thing that we might be dealing with a little bit. Who's that, Judy? No, I see a glass, but the first one I thought I heard was Judy. All right. My bad. Yeah, there you go. That almost sounded like Judy for a minute, Glass. But in any event, here's Andromeda, M32, M110. So let's go. It's on YouTube. Oh, by the way, that's a picture I took. This is Orion that I took back in November. I don't know, you probably can you see that? Let me check this and see whether or not you've got that one. Yeah. Yeah, you guys are getting that. This is a picture of Orion I took not long ago. And as you can see, that almost looks three-dimensional. I was really proud of this. This is the first picture I ever took of Orion. And I really hit it out of the park with that one. And if you ever wonder about my friend Declan in Ireland, he made all of these little figurines for me, including that one. Sent them all to me. Yep, he does. It shouldn't be 3 minutes. Mine should be 30 seconds. All right, yeah, it's about 30 seconds. All right, so let's go see what else we have. So where are we right now? We're over here with Andromeda. Triangularum is another galaxy that's right there. We'll see whether or not that's too far for me to hit. Or I'm going to start hitting the house here pretty quick. While we're doing that, I'm going to go ahead and drop this down to about 8 seconds again. There, look at that satellite. No, actually that might be a star. No, that's a satellite. Well, that doesn't look bad. That doesn't look bad at all. Well, who cares? Who cares what they think? Tonight we're actually doing real science. Can you guys out in YouTube hear the Discord chat? Brahmin Legion, dude, how have you been doing? I haven't talked to you in a little while. It's good to see you. Come on in Discord if you want. The link's right to... Where is it? There's the link. Yeah, I'm really proud of that. I'm really, really proud of that image of Orion. That really turned out sweet. So now what we're doing is we're having a look at the Triangularum Galaxy. Now, in our local cluster, you know, the top 3 galaxies, the largest one is Andromeda. And then next comes the Milky Way, and then the third one is Triangularum, which is what we're getting ready to look at right here. So again, very dark. You might see a little star or two here and there, but it's very dark. So what we need to do is we need to go down and kind of maximize our viewing pleasure to where the actual data is. And that'll be down here. Yeah, we're not seeing crap. I think this is Triangularum down in here, but you see, look at this. I'm probably hitting a tree here. So it's just not, that's just not going to work for us tonight. Hi, who's this? Oh, Broman. How you doing, my man? Long time no see. Let me guess, you're doing Sovereign Citizens now. All right. Or just having a look at the telescope a little bit tonight. Now there's a couple of things that I wanted to have a look at here. Let's go see. Where is Cassiopeia? That was back up here, I think. Oh, really? Okay. Yeah, you know why, and that is there's no Discord going out on this one. I can... Audio input capture.
It's all right. Don't fuck with it.
Yeah, no, it's okay, man. I was just mentioning it in case you wanted to know. That's all.
Yeah, we don't need to be heard.
All right, well then you're not going to be heard. You are being heard now, but you don't need to be heard. I'll just turn you off. There, now you're gone. All right. Oh no, the YouTube's not growing a bit. Not at all. It's just cut. All I know is that Schrodinger's cat is taken off like a bad weed. He's got double my viewers now, and he started off, with a quarter of my viewers. So, but in any event, he's got some good content on sovereign citizens. But yeah, he's just gone. He's just gone apeshit. Now, the Heart Nebula, let's see if this is in an area of the sky that I can see a little better. Mm-hmm. Yep. It's just basically my scientific ADD. Yeah. Yep. So what we're going to do is we're going to turn off this camera for a minute. We're going to go back over here to astrophotography tool. Let's go see whether or not we can get a picture right here where we are. Because we've been moving around a lot, and what I'm going to need to do, no, it needs a camera. All right. Broman, if you're not talking, go ahead and mute your mic real quick. I'm hearing the little one in the back. Yeah. There's nothing wrong with that. Okay. So here's the Heart and Soul Nebula. Let's go ahead and see where we are with this. Once again, we'll do point craft. We'll indicate where the scope is. And see if we can solve that plate. Plate solving is when you look at the stars here. And what it does is it'll draw a triangle, like a little triangle from here to here to here. And then it'll draw a triangle from here to here to here. And then it'll look at the pattern of triangles and see if it can figure out what you're looking at. And it's already solved it. So this spot right here, there's the location of that spot. That's the direction to the North Celestial Pole. If I go ahead and hit sync like that, boy, there's a lot of noise out there for a second. Let's go ahead and see. Yeah, let's see. Yeah, that was Broman's. Huh. That was weird. All right. Well, in any event, that's where... This is where it says we are, so we're going to go ahead and hit sync. And then look up here. I can hear you. So the telescope was actually looking here by the Fishhead Nebula. I wanted to look at the Heart Nebula, which is over here. So what I did was I directed it to go from where it was to where it was supposed to be pointed. Now, let's go ahead and see whether or not we can see anything with that. I haven't had a lot of luck getting nice nebula on camera here. So let's go see what this looks like. We'll bring up the ZWO-294, which is the Wolfie camera. Well, we're getting something there. I'm thinking it might be the green. Yeah, I've got a light pollution filter. I'm thinking about using a hydrogen oxygen filter though. Yeah. That's what God invented. That's what God invented tracking for. That was with a light pollution filter. My shot of Orion with that. That was a. Yep. Yeah, mine. They green. It's real green. I may be able to screw with these a little bit and see if I can get a little better shot. All right, so now we've got an image. I'm in northern Michigan. Oh, that's a nice one. Now, this is actually the Heart Nebula. We're looking right at the Heart Nebula right here. You see the little bit of pink right here? The Heart Nebula actually is a big object like that. Let me show you what it looks like. So if we get a little closer, that's where we're pointing right now. And this is the Heart Nebula. See how it looks kind of like a heart? So we've got the Heart and the Soul Nebula. Now with the Hyperstar system, I'll be able to get both of these in the same shot. I'll show you, give you an idea of what we're looking at right now. So, we have no lens on this. The telescope is the Orion. The sensor is the ZWO-294. And that's more or less what we're looking at. Here's the top of the image. Here's the bottom of the image. But you see, we can't even get this entire nebula. Now, when I get the Hyperstar system, instead of having that little box right there, the box will actually be about this big, because it makes it a very short focal length. It makes that 2,500 millimeter focal length for the Meade. It drops it down to about 400 millimeters. And it's a 10-inch, so we get a lot more light coming in. So we'll be able to pick these up a lot easier. I don't know, we can try. Tell you what, let's go over here to the Soul Nebula for a minute. I want to see maybe whether or not we can get a little better shot of that. I don't think we're going to need to plate solve again on that because it's just a short little move. But you see how I moved the telescope from over here, right over to here? Now let's have a look and see what we have. Let's get a full image over there and see what it looks like. All right, Roman, thank you very much for stopping by. Now, if you... Oh, I will. Okay, so here we are. We've moved over a little bit. Let's go ahead and let it have a full image and see what it looks like, okay? Let's go see. We got anything going on here in the chat? We had our little talk with Sean a little earlier. He's selling some really nice telescope equipment. I put up the Discord. You had some interesting people join the Discord today, bro. Glass? Mm-hmm. Cool. Well, all right, so what we're going to do right now is a couple of things. First, I'm going to set up and I'm going to take some images of the Sol Nebula, which is pretty much right here. But in order to figure out how to best expose that, I'm going to go down here to the histogram. Now, when you're dealing with SharpCap, once you have your sensor evaluated and it knows what your sensor can do, you can go hit this little brain right here. And you can figure out your exposure and gain based on either maximum dynamic range or unity gain, which means 1 electron per photon, basically. But we generally use max dynamic range. And if we sit here and have it measure, what it'll do is it'll change the settings on the camera a little bit, and you can see the histogram down here is moving around a little bit to kind of balance out the colors and such. But it'll sit there and go through this for a couple of minutes. And then what it'll do is it'll give you the curve of your sensor in your camera, and it'll give you a recommended exposure time, and it'll give you a recommended gain and dark setting. And then it'll tell you if you want to do a stack, how many images you should take in order to stack them up. And I'm going to show you what stacking is here in a minute. Yep. So give it a little while here. And again, this is SharpCap, which is a really nice imaging software, and it runs you all of $10 a year. So it looks like it's still measuring. Give it a couple more minutes. But you see how the different colors, see this particular telescope that I have is called a triplet. Now, red, green, and blue are your main wavelengths of light, okay? And each one, when it goes through a lens, has a slightly different focal plane. And as a result, what'll happen is that you will get little rainbows around your objects. Now, if you have a doublet, that's with a single lens on your telescope. If you have a doublet or two lenses on your telescope, what it'll do is it'll take two of those colors and it'll bring them into focus at the same point. One lens handles, say, red, lens handles green. Now, with a triplet, which is what I have, you have three lenses up there, and all three colors are brought together. So here's our data. Now, so for example, here's the sensor data. And my sensor has got a step here at 121 gain, where it suddenly becomes a lot less sensitive. So you want to have it at 121, and that's what it's recommending. Optimal exposure time for this particular object is in an area of the sky is 29 seconds, and it wants me to do 124 exposures. Now if I hit apply, all right, here's my gain. 29 seconds, gain is 121. Everything's all set in here. So now I can close that out, and that's what I'm seeing. So I'm going to close that real quick. Now, auto zoom is about 20 to 25%. I'd actually like to get it a little bit less than that. No, it won't do it. That's the maximum that it's going to do. So that's 20%. That's a little bit more. So here's the area of the nebula. So let's go ahead. We've set this up for the Sol Nebula. We're going to start capture on this. We want to go ahead and do about 130 exposures at 29 seconds per exposure. So how long will that take? Take about an hour and 5 minutes or so. So we're going to go ahead and hit start. And what it's going to do is it's going to start taking images of this same spot in the sky. You know what else I need to do? My bad. What I need to do here is I need to go ahead. So it's picked, I'm going to do what's called guiding. So it's picked a star right here that's out in the corner. And now what it's going to do is, see how it's got that locked into the crosshairs? The guiding software is going to keep that star right there in that crosshair. And as you see, it's making tiny little adjustments to the mount. Makes a little adjustment every 3 seconds to keep that star right in the center. So let's go back here. That's pretty good. I think we only had 1 or 2 little frames. Yeah, we had 3 frames. So the first 2 will probably be kind of crappy, but the computer will get rid of those. But you see, basically what we're looking at, see how there are little tiny tails on some of these stars? That was taken before the guiding started. Let's see if those get nice and pinpoint round. There, you see how they're nice and round now? Now, while it's doing that, let's go on over here. Now, on our desktop, we're going to have a folder here called SharpCap Captures, right here. Today is the 9th. We're taking the pictures of the Sol Nebula. And there they are. Now, remember the first couple here were kind of crappy. So we're just going to get rid of those. We also don't need these 2 particular files right here. So we're just going to delete all of those. They're gone. So here we have 3 images of the Sol Nebula. Very good. Now we're going to go down here to a program called Deep Sky Stacker Live. Here's the stuff on Orion that I did a little bit earlier. We're going to go ahead and stop that. Go up here to this file. And we're going to go down here and select our Sol Nebula images. That's 50 stacked images of the Orion Nebula, by the way. Let's go ahead and monitor. Okay, here's the Sol Nebula. It's starting to pull those images together. Give it a second. What it's going to do is it's going to start taking those images and it's going to put one image on top of the next. And it's going to line up all of these individual stars from one image to the next. So you see how this star here is kind of white, and the area that's around it is kind of black. Now, on all of the images, once these are all lined up, that star will be white in all of them, and the area around it will be black in all of them. So as you stack it, you're going to get an average of all of these colors. And what that ends up doing is it tends to make it a lot sharper. Now, the other thing that I want to do is, you see how this is all just kind of black space and white stars? All right. We have a little bit of a histogram up here. I always like to bring down the white just a little bit so none of these are getting blown out. The other thing is the black actually looks pretty good in here. But what we want to do is we want to have a look at the midtones. Let's see if we can bring those down just a little bit. See if we can find some of that nebulosity in here. And it's not really doing a whole lot, is it? Let's let a few of those stack. Let's go see if we can start seeing any of the nebulosity in there. We may end up having to do it. We may end up having to do it in Photoshop and bring the colors out in Photoshop. This is kind of just a quick live thing that we can do. So we'll let that run for a few minutes. And in the meantime, you guys can have a look at my Patreon, and you can have a look at the memberships to the channel, and maybe even a super chat or two. So let's go see what we have here. Let me give you some links here. Yeah, Extra J, SharpCap is a really nice imaging software for astrophotography. I have a what? I have a new channel? Oh. All right. Oh. Okay. Well, that's fine. There's the Patreon link. So these are the stacked images right now. We're going back here to SharpCap, and these are the actual raw images. Yeah, those are capturing nicely. And right now we've got about 16 or so frames working on the 17th one. Let's just let that run for a couple minutes. just to kind of give you an idea what the plan is, I want to get a few more images of the Sol Nebula right here because I simply want to practice working on the nebulae in Photoshop a little bit. But when we get done with that, we're going to go over here to the constellation, the zodiacal constellation Taurus, the bull. And Taurus, you know, of course, has got a body, and then it's got these long horns here. Part of that is something called the Pleiades, which are really pretty. And what I'm going to do is I'm going to see if I can get a little shot of the Pleiades. These are also called the Seven Sisters. And there they are right there. We should be able to get most of that, as you can see by the size of my image. We should be able to get most of them. And, you know, if you look at them, there's a dust cloud between us and the Pleiades, and that's what we're looking at right here. This is not a nebulae that's in the Pleiades, but we may be able to capture this a little bit with some long exposure images. So we'll go ahead and look at that for a little while and see what the stack's looking like. Really? A question? Extra J. Yeah, the eyepiece that I'm using, there are two types of amateur astronomers. They're the visual guys that, you know, go out and spend thousands of dollars on eyepieces. And then there are the guys like me that use cameras. And I've got a couple of cameras that I can use, including you know, just my regular old Canon. I have an adapter for that. And I can, you know, that's a really nice camera, even though it's a pretty inexpensive one and a rather small one. I've got a Canon Rebel SL1. I have some dedicated Astro cameras, one of which was donated by Wolfie6020 to the channel, and that's called a ZWO294. It's a color camera. And then I have a ZWO120 on my guide scope, which is a black and white camera. And you can see the images from that right here. What you use a guide scope for is basically just to get a picture of some stars, and then what you do is you put the crosshairs right here on one of the stars, and it'll actually make tiny adjustments to the scope in addition to the normal tracking to keep that star right on the crosshair. I'm not real pleased with this shotgun pattern out here. I mean, this mount is jumping all over the place. I don't know if I don't have the telescope well balanced on it. But the images itself that it's taking, you know, it's not shifting around very much. You got nice little round stars here, and these are really, really good. I'm going to have a big project coming up here in the not so distant future, and that is I'm going to do a very detailed study of the moon. It's broken down into like 17 different sections, and we're going to go over every freaking crater and lava tube in each of the sections. So, and then we're going to have a look at them as well through various phases of the moon, so you get the interplay of the shadow and you can get some idea of some 3D effects with it. It's going to be really nice. You know, it's going to take 2 or 3 months for me to put the gear or put the images together. What I'll do is when I gather the data, I'll probably have a live stream like this. And then what I'm going to do is I'm going to organize all the data and put them together in a series of weekly shows for about 6 months. And that'll be over on Common Sense Science. Okay. All right, so I'm kind of tired of looking at this. I think we've got enough images, so I'm going to go ahead and stop the capture. Now what we're going to do is we're going to see if we can have a look at the Pleiades. So let's back up and see where we are here a little bit. There's the Pleiades. Yeah, well, I'm probably going to go it's going to take me half an hour to take the telescope apart. But what I'll do is I'll go have a look at them in the morning, and I'll add widgets to everybody. Yep. Okay. Okay. Well, I don't think that they've got access to certain rooms. Oh, why'd that pass it? That doesn't look good. Hang on, something's going wrong here. Yes, something's going on with it. We're going to bring it back and park it real quick. That's too far down for me to see. That's a pity. The mountain may have frozen. I'm going to disconnect the telescope real quick. I'm going to go on out and manually put that thing back up in the park position. And yep. Great. All right, give me a second. I'll be right back. Well, I figured out what happened. The cables were all twisted. The mount had spun around and twisted all the cables. So, yeah, that wasn't cool. So let's go back here and we'll turn ASCOM back on. All right. All right, so that's good. Now let's go ahead and ASCOM's working again. Go to telescope control. Let's see if that'll connect. It did. So now the computer's talking to the telescope mount. We're going to shut that one down. Let's see, we got anything cool to look at out here? I'm thinking Beehive Cluster might not be a bad thing to look at. This is Messner 44. What we're going to do is we're going to go on over here and we're going to move it. It seems to like to move through astrophotography tool first, and then it'll start moving on command through Stellarium. So I'll show you how to do this. So let's go to the objects. These are the deep sky objects, stars, etc. All right. Messner 44 is a deep sky object. So that'll be in here. Let's find it. Come on. There it is. Beehive Cluster. That'll be okay. We are going to hit the Goto. And now what it'll do is, okay, it's looking for the Beehive Cluster right here. And here's where it is right now. So you see how it's starting to slew over? And it says it's slewing up here. We'll wait until that's done moving. Then we'll take a picture and see where we are. Give it just a moment. Okay, got the right camera on. It's settling. Okay, with a C there, that means that it's where it's supposed to be. So let's shoot an image. This is a 4-second image, I think. Yep, 4-second image. Got a few stars out there, a nice clear sky. Good sign, good sign. Re-auto stretch it real quick. Now we're going to go up here to Point Craft. Put the position of the scope in. See if we can figure out where we are. It can take up to a minute to actually find. Remember, what it's doing is it's making triangles with all these little stars, and then it's comparing the pattern of triangles to the star map. And we know that it's solved when it says solved over here, and you'll see a little compass pointer up here. been working on it for 37 seconds. While we're doing this, I'm going to go ahead and have a look over here at the chat and see if anything's going on. Not too much. Yeah, I'm not muted right now. I wasn't talking here earlier. Yeah, on the YouTube hears me too. It's taking a while to solve here, isn't it? It's been 102 seconds. Make sure we aren't doing anything wrong here. You know, one of the problems that you run into sometimes is that if you go too far, the error that's induced by the movement of the scope may mean that it's too far to accurately solve. Because when you want to solve, it's got to be within a certain distance of where you think you are. Yes. Make sure it's Team Skeptic, though. So you know that it's Team Skeptic. Because I've seen some porn bombers use his... I've seen some porn bombers use his icon and pretend that they were him. So you see how far we came from the North Celestial Pole. So we're going to go back up here to Polaris. And then what we may do is we may come down a little slower and with a little less jump. Okay, we're up here by Polaris. Give it a second, it'll settle. Okay, there it is. Let's go see what we have here. Okay, so that's changed. I'm going to put our scope position, we're going to hit solve. The scope should be pretty close to Polaris right now. So we should be able to solve here. Then we just need to go out a little ways, you know, maybe 5 degrees and solve again. Okay, so it's solved. Let's sync that. See where we are. Okay, so we're a little bit off. Let's see if this will solve. Okay. And we're waiting. Good morning, Chris. How are you today? All right. So we've just done a plate solve. You see our compass rose is up here. Here is the actual location of our scope. And if we look over here, we'll see there's where the scope is actually pointing rather than where we thought it was pointing right there. So now we know that. Let's see if we can go to the Beehive Cluster. We'll do another plate solve down in this area here too and compare where our scope thinks it's pointing to where it actually is pointing. Okay, so it's settled now. We'll take a shot. Oh, by the way, we need to stop this. That may be the Beehive Cluster right there. See, we got a bunch of stars here. The Beehive Cluster is a rather small cluster. And okay, so it's solved. We sync. Hey, we're pretty much dead on, aren't we? Look at that. Nope, didn't. Now this thing right here, you see we just had to move over just a hair and we should be directly on the Beehive Cluster right now. So let's go ahead and turn this camera off. And go over here to SharpCap. We'll turn that camera on. You can't have the same camera on in both programs at the same time. So I have to turn it off in Astrophotography Tool, which is my plate solving software. Then we're going to go over here to SharpCap, which is more imaging. Give it about a 15-second exposure. What's our gain looking like here? Well, we want to gain up at least 120. Yeah, 133 is good. And there's the Beehive Cluster. Now if we want to get a little better, we can actually auto stretch it with a little lightning bolt here. And this is the Beehive Cluster right here. See, all these stars are kind of all packed in a little bit together. but that's the Beehive Cluster. That's the first time I've looked at that. And there it is. See? Just got all these little stars packed together. And there's more stars there than there are around them. That's what a cluster is. But there's some nice clusters out here too. Let me see if I can find something that's kind of cool. I wonder if I could see Hercules tonight. No, let's go see. Yeah, it's going to be below the horizon. Give me a second. I'm going to go grab my iPad, and I want to have a look at something real quick. I'll be right back. I'll just leave it up there on the Beehive Cluster for a minute while I go pull this up. What? I don't know anything about the bots. Okay. Okay. All right. I should be able to see that. All right. This is M53, which is a globular cluster. Yeah. Yeah, Nathan was kicked from the service. I've got no idea why. Yeah, I may have a different name. Are you sure? I don't care. I'm not going to pay much attention to him. Yeah. Well, that doesn't look anything like the picture. Let's try it again. Well, that's what it says. Oh, that's what I'm looking for. Now, why can't I see that? So let's see now. I've got these stars right here, and I got those stars right there. Let's go see what I got. You know what the problem might be is that I don't have enough magnification on this to see what I'm looking for here. So we're gonna try another little trick. Give it a 30-second exposure. There's supposed to be a globular cluster right here. And I'm going to go see if I can find it. Looks like it's very distant. So we're going to try something else with the camera here, which is kind of a cool trick. I'm looking for Messner 53. Yeah, Guy, to answer your question, yes, the scope is outside. It's probably 100 feet away from me right now. And it's connected to my internet router via a LAN cable. And there's also a power cable going out to it because I have a little cart that I use that's got a computer on it and a battery pack and some things like that. So that's what I've got out there. And I take over that computer using remote desktop from inside, so I can sit in here next to the fireplace and I can do all this cool stuff. So According to this, there's supposed to be a globular cluster right in the center here. So what we're going to do is we're going to increase the magnification a little. And let's see if we can find it. What's that, Glass? Yeah. Yep. Mm-hmm. Well, that's exactly what I plan on doing with this. I want to see if I can find this cluster. You see how these are kind of streaked a little bit? It's not doing a great job tracking right now. What I've done is I've increased the magnification on the camera a little bit. And now what I'm doing is I'm trying to have a look through all of this, see if I can find that little globular cluster in here. It should be right in this area right here. Yeah, those stars are actually looking pretty decent. But I think that those are all stars. I don't think there's a cluster in there anywhere. See how you get these little double stars sometimes? I don't see anything that looks like a cluster up in this area. Oh. No bueno. Yeah, it looks like we got a little bit of a streak right here. That's the tracking not being perfect. Well, I don't see anything here. Come on. Better. Well, that's not any good. Well, let's see if Messner 3 is available. As soon as that settling turns to a C, we can take a shot. Okay, so it's solved it. We'll sync it. See, we're going to try and find this cluster right here. Just simply because I haven't looked at any clusters, so I have no idea what they're going to look like with this. Come on, is this thing going? Yep, it's coming down. So that picture's not changed at all. Let's go ahead and restart the program and see if that helps. Do a plate solve here. I don't have a lot of stars. It might be a little difficult to get a plate solve. Oh, but we got one. Let's go see where it says we are. So you see the telescope is not pointing where we told it to go. We told it to go right here, and it's actually pointing right there. So what we have to do is we have to bring it in. And now it should be pointing very accurately at our object. I think what we'll do is we'll go ahead and give this one here a shot. You know, if we get a really nice image, maybe we'll have a look at something else. If we get kind of a crappy image, one that doesn't look all that particularly interesting, I think we'll probably call it quits for tonight. And try that again. I can hardly hear you, Glass. What's that? Why? I'd love to have 1,600 members. Okay, so there's our data. Auto stretch it. There it is. Ha! How do you like that? I'll be damned. We found it. This is Messner 3. It's a globular cluster. So what we're going to do is we're going to have a little closer look at it here. Now, because we have a good target here, see how we're getting a little bit of streaking at this real high magnification? So let's see if we can go ahead and guide a little bit here. And there's the globular cluster right there in the finder scope. Yeah, whenever I get up. Something's wrong with this. Let's restart that and see whether or not. See how that when even though the scope itself is guiding, there's still a little bit of streaking there. Okay, according to this, it's guiding now. Let's see if that gives us a little better image. We'll wait for the next one to come out and see if it's a little better than this. See how it's just kind of a little blurry right here? I don't see an awful lot of streaking though. Got a lot of streaking in that one. Give it a second. Let's see what the next one looks like. See, this is just a little movement of the telescope. There we go. That is what they call a globular cluster. That doesn't look too bad there. Let's look at M58. Let's see where M58 is and see whether or not I might have a chance of seeing that. Oh, I can see that one too. So in any event, that's the cluster right there. We're going to see whether or not we can see this next one, M58. So the M58 is going to be right there. This is actually a galaxy. It's a barred spiral galaxy within the constellation Virgo. Let's go see how easily we can find it. Of M58? Well, that sounds like it'd be a good thing to look at then. These are all places I've never looked at. All right, so let's connect that. Okay, we've got the C. We're going to take a 4-second exposure. Okay, there's 4-second exposure. Put the scope position in and see if we can solve for it. And we can. Hit sync. We are slightly off. All right, so there we are. Let's go ahead and turn the camera off here. We'll go over to SharpCap. Going to select our color camera. Okay, that's RAW 16. Give it a 30-second exposure. Now we'll wait for this exposure. We'll see what we have. Then we'll go ahead and stretch it a little bit, do a little auto stretch on it. See if we can bring out some details. $2030. Yeah, that's going to be small for me. Well, I don't know about you. I don't see crap. Let's go ahead and do a little auto stretch here. I'm thinking that's probably it right there. Yep, that's it right there. All right, so what we're going to do is we're going to do this in two parts. First of all, we're going to go ahead and start guiding. But I think we're dead on it. Okay, so it's picked a star there. Or it's picked a star there. It's going to start guiding on that star. The next thing that we're going to do is we're actually going to go... I think I'm going to go ahead and hit this histogram, and I'm going to see if I can get a nice recommendation for some images. $68 million light years away. About 25 times as far as Andromeda is. How was that? Oh, it's just a star that had a little jump in it, it looks like. Here's M58. What we're going to do is we're going to go ahead and do a capture on this. Well, we need 2 or 3 images to go ahead and start the stack. So what I'm going to do is I'm going to go get rid of the garbage images here first. Go up here to SharpCap. That didn't work out so well, did it? Now it's going to start off with the first 4 images or so stacked on top of each other. And there's our galaxy right there. You can see the arms just barely there. M109. I should be able to hit that. Well, according to this, well, in any event, that's M58 right there. I'm going to get a few more images of it, and then I think we're going to try the Sombrero Galaxy, which is nearby. That's about half the distance away, so it'll be a little bit bigger. I'll be back in a second. Had to let Otis in for a minute. All right, so how many images do we have here? Let's see how many images we have. Well, we got 19 images. Let's go ahead and finish this one off. Now we got 20. So let's go ahead and stop the capture of that. Looks like we got a little bit of a streak on that one. All right. Now, the next one that I want to hit is M104. So, we're going to go ahead and find M104. This is called the Sombrero Galaxy. And it's half the distance of the last one. So we might be able to see this one a little easier. I'm going to go ahead and slew over to that. While we're doing that, we're going to go ahead and turn this camera off, put the plate solver camera on right there. Are we there? Yeah, we're there. Let's go ahead and take a picture and see if we can plate solve and get to the Sombrero Galaxy here. And there we are. Scope position. Let's solve it. Si, senor. Oh, give it a couple minutes here. There we go. We're solved. Where are we? Ah, nowhere near it. Where does it say we are? Wonder why we're way up there. I think we probably ought to plate solve this one here again. So we'll shoot a picture. Up there it is. See it? There's the Sombrero Galaxy right there. It's actually not in too bad of a position. Oh, he hangs out once in a while. Well, there's the Sombrero Galaxy. Let's go ahead and put the other one up. Let's do our imaging camera here. Come on. There you go. So, raw 16. Come on. Raw 16. Go ahead and give it about a 30-second expel. Let's give it a minute. Give it a gain of about 140. Now we just wait for the image to come through. That's not a good sign. That's not a good sign at all. Yeah, you see the reason that that's all green like that? I think I'm pointing at the ground. That's not where I'm supposed to be. According to that, I'm not there. I think I'm going to. Yeah, something weird's going on here. Let's bring it up high again and see. Wonder if my cables are getting twisted again. Yeah, it's that might not be a bad idea. That looks like the galaxy right there, but for some reason it didn't read it. I'm thinking the telescope's lost right now. I think it got stuck on something or other. I'm gonna go check it real quick. I'll be right back. Yeah, well, there's your problem. It's 10 degrees off. That's what happened. And my telescope got stuck on something. It's frozen. There's a lot of ice hanging off of it right now. It's really cold out there. Tell you what, let's go ahead and shut this down. Make sure that's not on. Okay, good. Should be kind of pointing up in the general direction of Polaris right now, so it's a good place to go ahead and get started. The Great Hercules Cluster should be up. Yeah, grab one for me too, would you? Yeah, it's called an observatory. I've got a dew heater on it, so at least the lenses, the glass isn't icing up. I've got an AstroZap dew heater, and I'm really, really pleased with it. It does a great job. Actually, that's not right. That's not set up right. What? Yep. Well, that's what I'm going to do with this one eventually. One of these days, you guys will actually be able to control the scope from your end. Yeah, you'll be able to control the scope from your side. All right, so that's synced. I've got that. Now, let's bring this. All right, what was I looking for here? When you're looking at the distances that you can get on Earth, stars are going to be pretty much parallel. They're going to look exactly the same everywhere. The distance is too small. Yeah, now the moon you might be able to triangulate. That would be kind of cool, wouldn't it? Down in Australia. We get Wolfie to do it down in Australia. They actually have binocular eyepieces that you can do. You know, I got a really nice set of astronomy binoculars. Some 25/100 binocs. And, you know, you can see the Orion Nebula, you can see the rings of Saturn with those things, moons of Jupiter. I've loaned them. Yeah. I loaned them out to my practice manager so they could have a look at Jupiter and Saturn. You know, it's set too far. You know, it's already set by the time I got home, and it's too far out in the west. I can't get to it. So I figured I'd loan them the binoculars so they could look at it. Yes. Yeah. That the whirlpool? Is that the... Yeah. Yep. Well, this didn't... Well, this is not working. Well, unfortunately, I think I tried to reach too far with this one. So let's go back up a little bit more towards the pole and see if we can get a... Let's see if we can get a position here. We still have problems with water in Flint. All right. Let's see if this is close enough to the celestial pole that I can solve for it. I keep trying to go too far away from the pole, you know, with a direct slew. What you need to do is you need to locate where you are at the pole, and then you need to go out a few degrees and solve for that, and that way there your right ascension is a little more accurate, and then work your way out to these objects that are more down towards the horizon. What? All right, man. Yeah, I'm gonna get out of here pretty quick too. All right. Just make him Biden fanboy. Oh, it's solved. All right, so it's solved. No, it's solved where I was. Now we're going to go right on over here. All right, so that's solved there. Let's bring it down to that star right there, and then we're going to go out there and solve. Good night, Glass. Okay, so now we're there. Let's go see if that can solve there now that it knows where it came from. Trying to get down to the Great Hercules star cluster is what I'm trying to do. That doesn't look any different. Just give me a... Hey, is the Beeve here? Brainy Beaver. That gave me some stars. Let's see if we can solve this one. Now, if we solve this one, we can go to the Hercules star cluster next. We should be able to hit that pretty accurately. It's kind of low towards the horizon. Oh, I think it did. Let's go see. Yep. All right, so let's solve that. That is the great star cluster in Hercules, and that was my ultimate target. All right, let's go see if we can solve for this. Okay, that's done slewing. Ha ha ha! Look at that! Look at that! There it is. Whoops, don't want to do that. But we found this great star cluster of Hercules, and we're going to sit here and play with that here in just a second. Okay, we're going to sync there. We are, what? We already did. We already did. One of my favorite Canadians. All right, so that should be balls on right now. We're going to disconnect the camera here. Go over here. Bring our good camera up and our good imaging software up. Give a little depth. "30 seconds should be good. Now we're $2:30. All right, so there is the Hercules star cluster. It's a shitty picture of it, but there it is. This is the Great Hercules star cluster. It's a globular cluster of quite a few stars, at least 4 or 5. Okay, there's a star that I picked. Let's see if it'll guide on it. Come on, bitch, you guide. There we go. That's the star cluster right there. And it's guiding. So let's go on over here, give it a second to get a good image or two with some good guiding on it. See what that looks like. That's his job. Yeah. So that's not too bad. Let's reduce that magnification just a little bit. But that's the Great Hercules star cluster. And if you look at it, there you go. That's kind of cool, isn't it? Yep, and that's Holden right there. So that's the Great Hercules star cluster. Now, our last target for the night, and it will be the last target of the night, because as you appropriately mentioned, it is 2:30 in the morning here. I'm going to stop our guide there for a minute. Distance to Hercules, 7,700 kiloparsecs, 25,117.4 light years. Let's go find M51 here, because I don't think I've ever seen M51 in this. Yeah, it's not too far away. Let's go see if it'll slew there. How far is Betelgeuse? I know the Orion Nebula is about 1,300 light years away. Okay, so we're going to go through our procedure again here. We got to turn the camera off here, turn the camera on in astrophotography tool, put the scope position in, and let's take a shot and see what we got. Okay, I don't see it there. Let's go ahead and solve and see where we are. Betelgeuse is in Orion, yeah. It is the right shoulder of Orion. And it's... Don't say it! Don't! Now you got him. There we go. That actually didn't go too far away, did it? Well, according to this, we should be balls on. So let's disconnect that one. We'll go back up here to this one. Bread rum. Bread rum. Okay. Okay, we're going to, while we do that, uh, 658.14 millimeters. Well, this reads it off, and it gives me my field of view as well, which is kind of awesome. Yeah. No. Okay, so that looks awful damn black. I lost my camera. Yeah, the cameras are gone.